Okay, in this tutorial here, we're going to be looking at how do we use a spectrometer. In this case here, we have a visible spectrometer. It's able to send in different wavelengths of light here. For the visible spectra, it's very useful when we're studying solutions that are actually colored. Sitting in front of me here are transition metal ions here. We've learned in our course how come they're colored as well. But just let me introduce to you how we use this device here. This spectrometer here is connected to my iPad via Bluetooth. We're going to be filling up our solutions into these plastic cubes here called a cuvette. For a lot of these cuvettes here, you'll notice two sides here are hashed or frosted, two sides here are a little bit more clear. For our spectrometer here, because the light source is going side to side, you're going to want to make sure that the most transparent, the clear side, is also going side to side as well. So we load up the solution in the top here, and we just put the cuvette here inside this chamber. Before we begin, we do need to calibrate our spectrometer. So we're going to start off. I've opened up my Pasco app here. I'm going to press record in this lower left corner. It's going to remind me that we want to calibrate. First thing I want to calibrate for is calibrating a dark solution. This right here should be automated. They won't turn on the light. They're just going to sense what does it look like if there's no light going through. If you're not sure, you can actually cover over the top here, try to block out some of the light. Let it sense what a dark solution would look like. It's going to calibrate that as 0. Second thing we're going to calibrate is calibrating a reference solution, also sometimes called a blank solution. So I have another cuvette here. This is just filled with water. For all these transition metal solutions, the solvent is water as well. What I want to do here is I want to send in the light through the cuvette here as it passes through the plastic material, as it passes through 1 centimeter deeper solution as well. I want that to also be zeroed so that later on I want that to be subtracted from my colored samples. So I'm just going to put that into my solution here. Again, the clear side by side. We're going to press the calibrate reference button here. Again, it's going to set that there. It's going to learn that it's 0. And then what we can do is we can start analyzing our colored solution. So we're going to be first looking at an absorbance spectra. So what's plotted on my graph here is we have absorbance. We're sending in a bunch of wavelengths. You'll notice that the calibration was successful here because everything is zeroed at the moment. I'm going to take out my blank solution. Keep that handy because sometimes you might need to recalibrate. First solution I have here is a nickel chloride solution. So I'm going to put that in here. And you'll notice in real time, it's actually plotted. We're sending in these many wavelengths of light here, and these are the relative absorbances here. We already have a nice real-time sample of the spectrum here. And we notice in this case here, although it does look green to us here, it's actually absorbing in the visible spectrum between about 400 to about 700. It actually has an absorbance peak in the red region here. There's also another peak here in the purple. Remember what's happening here, it looks green because it's the complement color, in this case here, the red that's being absorbed. So let's just compare the solution here. I'm going to pull out the nickel solution here. I'm going to instead put in a cobalt solution. Again, make sure that the clear side is following the light here. And you notice the curve is actually different. It looks red to us, so it's a different complement color that's being absorbed. In this case here, there's a bluey wavelength that's absorbed here. So just give you a qualitative comparison between these 5 solutions here. This is a solution called potassium permanganate. It's a really, really deep purple. Just to show you that spectroscopy here only really works when we deal with fairly dilute concentrations. If the concentration gets too high, the light scatters and it can't quite get through. You'll notice that we're saturating the detector at an absorbance of 3. So what you can do for this one here is you can dilute it down. Just keep track of your dilutions there, and then we can create a calibration plot from that. Here's another problem here. I have an iron chloride solution. This one here, annoyingly, sometimes it forms a precipitate at the bottom. Again, solids aren't the greatest for the spectrometer here. I'm going to put this in here, and again, what's going to happen is we may accidentally have saturated detector. You'll notice for each of these solutions with different colors here, they have a different absorbance spectrum to them. I'm going to do this last one here in a little bit more detail here. Starting off here with our copper 2 sulfate solution. It looks blue to us. As I pop it in here, I can make sure that the clear side is side by side. It's all referencing the blank. It's already subtracting off, traveling through 1 centimeter deep of water here. Notice that I am slightly saturating the detector here. What you'll want to do here on our Pasco app here is you can move this dial here. You want to move your cursor where the absorbance is the maximum. We can press a check mark there. Now we've actually told the spectrometer I'm going to be sensing the rest of my solutions at a wavelength, in this case 662.5 nanometers. That's going to be the most sensitive. If you then dilute the solution from there on out, the absorbance will just steadily decrease. Now that I've set on a wavelength here, what you can do here is you can stop the recording. We know that this is going to be our lambda max. We're going to flip over here to the concentration tab. It's knowing to send in 662. And now what we can do is we can press record again. If I had different concentrations, different successive dilutions, we're going to do a lab on this, creating a calibration plot. You're going to see here it actually is reading the absorbance reading. This is in real time, so this value might fluctuate a little bit here. You just press a check mark when you think it's sort of steadied out here. If you do want a transmittance reading here, you just press that transmittance button. Again, just check mark once it's sort of steadied out. Again, the assumption here is you would be testing different concentrations, steadily more and more dilute solutions here, and tracking a calibration plot. That way, once you have an unknown solution of this compound here, you can match it up to your calibration plot. Beer's law says there should be a linear relationship between absorbance and your concentration, and that way we can extrapolate or interpolate for the unknown. So we'll do another lab talking about calibrating this one here. Usually what I do is I just track down the real-time reading here. These default readings may or may not necessarily be the concentrations that we want. It's easy enough to take the values that we record. Usually we record both absorbance and transmittance. We plot it against our concentrations, and then we'll create that linear plot later on. All right? So if you have any questions, let me know. Thanks, guys.